Imagine living in a world where weather was a complete mystery. A devastating storm could appear out of nowhere, destroying entire harvests and sinking ships without warning. Sailors would set out on calm seas, only to find themselves battling monstrous waves hours later. Farmers would plant their seeds on a sunny morning, only to watch helplessly as unexpected frost killed their crops overnight. For centuries, humanity was at the mercy of these unpredictable forces of nature. But in 1643, one man changed everything, with nothing more than a glass tube and some mercury. In the modern age, predicting the weather was practically considered magic, a skill possessed only by the most superstitious fortune-tellers or the wisest of old farmers who claimed they could feel it in their bones. Weather forecasting relied on folklore, myths, and observation of animal behavior rather than scientific understanding. Red skies at night might signal fair weather, while aching joints suggested incoming rain. There was no systematic way to understand, let alone predict, atmospheric changes, until an Italian physicist named Evangelista Torricelli stepped onto the stage of history. A brilliant student of the famous Galileo Galilei, Torricelli wasn't satisfied with ancient explanations about the nature of air. While others focused on the heavens, he became fascinated with something invisible yet ever present all around us, the very atmosphere we breathe. Through a stroke of genius and careful experimentation, Torricelli created a revolutionary device, the barometer. This seemingly simple invention didn't just measure air pressure, it fundamentally transformed our understanding of the invisible forces shaping our world. It explained why pumps could only draw water up to certain heights. It revealed why atmospheric conditions change before storms arrive. And most importantly, it opened the doors to modern meteorology, giving humanity its first real tool to predict weather patterns. And the story behind this world-changing invention? It's even more fascinating than you might imagine. It's a tale of scientific rivalry, unexpected discoveries, and one man's determination to prove that even the air itself had weight, a notion that many of his contemporaries found absolutely ridiculous. If you love stories about scientific breakthroughs and revolutions that changed the world, don't miss this episode. Smash that like button, subscribe to the Modern Age Chronicles channel, and don't forget to hit the notification bell so you never miss our journey through history's most remarkable discoveries. For centuries, some of the greatest minds in human history were united by a peculiar belief about our world, that a true vacuum, a space completely devoid of matter, simply could not exist. This wasn't just a casual opinion, it was considered an absolute law of physics. Nature abhors a vacuum, they proclaimed, with unwavering certainty. This phrase, originally coined by Aristotle in the 4th century before Christ, had become scientific gospel. Greek philosophers, medieval scholars, and even Renaissance thinkers all subscribed to this notion. They looked at phenomena like suction and the way water filled empty spaces, and concluded that the universe itself actively resisted emptiness. When you drank through a straw, they believed it wasn't suction pulling the liquid up. It was nature's desperate attempt to fill the potential void you were creating. Even the great Galileo Galilei had struggled with this question. He noticed that water pumps mysteriously failed to raise water beyond 32 feet, but couldn't fully explain why. The mystery lingered, challenging the finest scientific minds of the era. Enter Evangelista Torricelli, a brilliant young mathematician from Faenza, Italy. As Galileo's student and assistant during the final months of the aging astronomer's life, Torricelli had absorbed his mentor's revolutionary approach to science. Test everything through experiment, trust mathematics above all else, and never bow to authority without evidence. While others were content to quote ancient texts to explain the world, Torricelli had a radical thought. What if air wasn't just nothingness? What if it actually had weight and exerted pressure? This might sound obvious to us today, but in the 17th century, this was a shocking proposition. Air was considered an ethereal element, not something that could be measured or weighed. Torricelli suspected that the mysterious 32-foot limit in water pumps wasn't caused by nature's hatred of vacuums, but by something much more mundane. The air around us was pushing down on everything with a specific, measurable force, and that force could only push water up so high. But how could he prove such a revolutionary claim? How could anyone demonstrate the weight of something invisible, something you could pass your hand through without feeling resistance? The answer, Torricelli realized, lay in a beautifully simple experiment, one that would challenge centuries of established thinking and open up an entirely new field of scientific inquiry. And the key ingredient for this world-changing experiment, not some rare substance or elaborate machinery, but something surprisingly common: mercury, the strange liquid metal already familiar to alchemists and physicians throughout Europe. Torricelli's insight wasn't just clever, it was about to turn the scientific world upside down, quite literally, and the vacuum, that supposedly impossible state of nothingness, was about to make a very dramatic entrance onto the stage of scientific history. In 1643, in a modest workshop in Florence, Evangelista Torricelli was about to perform an experiment so elegant and profound that it would permanently alter our understanding of the world. Picture this: a glass tube, roughly 1 meter long, sealed at one end, and a bowl of shimmering silvery mercury. What happened next seems almost too simple to be revolutionary. Torricelli carefully filled the tube completely with mercury, making sure no air bubbles remained inside. Then, with his finger firmly covering the open end, he flipped the tube upside down and plunged this end into the bowl of mercury. Now came the crucial moment. He removed his finger. Scholars and philosophers for centuries would have expected one of two things to happen. Either the mercury would stay completely inside the tube because nature abhors a vacuum, or it would all pour out due to gravity. But something utterly unexpected occurred instead. The mercury level dropped dramatically, but then stopped falling. It stabilized at a height of approximately 76 centimeters above the surface of the mercury in the bowl. Above that level, at the sealed end of the tube, was a space containing nothing, absolutely nothing. Torricelli had created what many had deemed impossible, the world's first artificial vacuum. But the true genius was in his interpretation of why the mercury behaved this way. While others might have concocted elaborate explanations involving invisible strings or mystical forces, Torricelli recognized the beautiful truth. The weight of the air around us, pressing down on the surface of the mercury in the bowl, was physically pushing the mercury up into the tube. The column of mercury wasn't being mysteriously suspended, it was being balanced by atmospheric pressure. And the exact height of that mercury column was actually measuring that pressure precisely. In that moment, the barometer was born, the first instrument capable of measuring the invisible ocean of air in which we live. Word of this astonishing discovery quickly spread through Europe's scientific community. For some, it was heresy, proof of the vacuum they insisted couldn't exist. For others, it was a revelation that unlocked new questions about the nature of air, pressure, and the very composition of our atmosphere. Here's something fascinating you might not know. Torricelli didn't choose mercury randomly for his experiment. He selected it because mercury is 13 times denser than water. This brilliant choice allowed him to create a reasonably sized instrument that could sit on a desk or table. If he had tried to construct his barometer using water instead of mercury, the tube would have needed to be a staggering 10 meters tall, taller than a 3-story building. Imagine trying to construct and manipulate a delicate glass tube that size in the 17th century. Torricelli wrote to his colleague Michelangelo Ricci about his breakthrough, saying, "We live submerged at the bottom of an ocean of air." This poetic description wasn't just beautiful, it was a revolutionary new way of understanding our relationship with the atmosphere. The implications were enormous. If air had weight and exerted pressure, then that pressure might vary from place to place or from time to time. And if these variations could be measured with Torricelli's new instrument, perhaps they could be correlated with changes in the weather. Suddenly, the mystical art of weather prediction had a scientific foundation. And just like that, with a tube of glass and a bowl of mercury, Torricelli had not only solved Galileo's water pump mystery, but had fundamentally changed humanity's understanding of the very air we breathe. Before Torricelli's invention, weather forecasting was little more than guesswork and superstition. Sailors would scan the horizon for telling cloud formations, farmers would observe animal behavior, and everyone relied on folk wisdom passed down through generations. Red sky at night, sailors delight. Red sky in morning, sailors take warning. These methods sometimes worked but often failed catastrophically. But everything changed once the barometer began spreading throughout Europe in the late 1600s. For the first time in human history, people could actually see atmospheric changes before weather conditions shifted. A sudden drop in the mercury column signaled an approaching storm, while rising mercury indicated fair weather ahead. This wasn't magic or folklore. It was science. Imagine being a ship captain in the 1700s. The skies look clear, the day seems perfect for sailing, but your barometer shows rapidly falling pressure. You decide to stay in port despite the promising appearance, and hours later, a devastating storm hits the coast. Ships that ignored their barometers were lost, while yours remained safely anchored. With this simple instrument, countless lives were saved as maritime disasters decreased significantly in the decades following its adoption. For farmers, the barometer became almost as essential as the plow. Why plant seeds when a storm is approaching? Why harvest if fair weather is predicted to continue? Agricultural productivity improved as farmers made better decisions based on scientific readings rather than hunches. Crop yields increased, and food became more plentiful and affordable across Europe. But perhaps most surprisingly, the barometer quickly found its way into medicine. Physicians in the 17th and 18th centuries became convinced that atmospheric pressure directly affected human health and well-being. They carefully recorded barometric readings alongside patient symptoms, developing elaborate theories about barometric diseases. Some doctors even prescribed specific treatments based on air pressure readings. A fascinating medical text from 1682 by an English physician named Thomas Sydenham claimed that arthritis pain, breathing problems, and even mental disturbances worsened during certain barometric conditions. While some of these connections were exaggerated, modern medicine has actually confirmed that changes in atmospheric pressure can indeed affect joint pain, migraines, and certain respiratory conditions. Those early doctors were onto something after all. The barometer even became a fashionable household item for the European elite. Wealthy families displayed ornate wheel barometers in their homes, with decorative dials and elegant wooden casings. These became status symbols, showing that the owner was educated, scientific, and modern. Ladies and gentlemen would check their barometers each morning almost as routinely as we check our smartphones for weather updates today. One of the most remarkable outcomes was how the barometer connected distant weather observations for the first time. Scientists began setting up networks of barometers across countries, noting how pressure systems moved and changed over time. These became the first rudimentary weather maps, laying the groundwork for modern meteorological forecasting. When a storm hit Paris, London knew it might be next. This systematic approach to weather prediction was revolutionary. Torricelli unfortunately never witnessed most of these developments. In a tragic twist of fate, he died in 1647, just 4 years after his groundbreaking discovery, at only 39 years of age. His early death from typhoid fever cut short what might have been an even more brilliant scientific career, but his legacy lived on through his invention. The barometer didn't just measure the weather, it fundamentally changed humanity's relationship with the natural world. For the first time, people could anticipate nature's moves, prepare accordingly, and gain a measure of control over forces that had previously seemed entirely unpredictable. Torricelli hadn't simply created a scientific instrument. He had given humanity power over one of its oldest adversaries, the capricious weather that had dictated human affairs since the dawn of civilization. Did you ever imagine that a simple tube of mercury would revolutionize science and change the course of human history? If you're enjoying this journey through scientific discovery, hit that like button and drop a comment telling us, what historical invention do you find most incredible? Subscribe to our channel for more fascinating stories from the past that shaped our world today. Great scientific discoveries are rarely accepted without a fight, and Torricelli's barometer was no exception. Behind the scenes of this revolutionary invention lies a dramatic tale of controversy, skepticism, and intellectual warfare that rivaled any political intrigue of the 17th century. When news of Torricelli's experiment reached the intellectual centers of Europe, it ignited a firestorm of debate. Imagine the audacity. An Italian mathematician was claiming not only that he had created a vacuum, something considered impossible for thousands of years, but also that the invisible air around us had weight and exerted measurable pressure. For many scholars steeped in Aristotelian tradition, these ideas weren't just wrong, they were heretical. One of the most formidable critics was none other than René Descartes, the celebrated French philosopher and mathematician who gave us "I think, therefore I am." Descartes, despite his reputation as a revolutionary thinker in other areas, remained surprisingly conservative when it came to the vacuum. In 1644, he wrote scathing letters dismissing Torricelli's interpretation of the experiment. Descartes insisted that there simply couldn't be nothing at the top of the tube. Instead, he proposed that an invisible, ultra-fine substance he called subtle matter must be filling the apparent void. He even suggested that this subtle matter was seeping through the glass walls of the tube or through microscopic pores in the mercury itself. In his mind, a true vacuum remained a physical impossibility. What's fascinating is how personal this scientific disagreement became. Descartes, who had built much of his physics on the impossibility of a vacuum, couldn't afford to concede this point without undermining significant portions of his own work. It wasn't just scientific disagreement, it was intellectual self-preservation. Meanwhile, in France, a brilliant young mathematician named Blaise Pascal heard about Torricelli's discovery and became immediately intrigued. Just 23 years old at the time, Pascal was already making waves in mathematical circles. Unlike Descartes, he approached Torricelli's claims with genuine curiosity rather than predetermined skepticism. Pascal realized something profound. If Torricelli was right and air pressure was supporting the column of mercury, then the height of that column should decrease at higher altitudes, where there's less air above pushing down. This insight led to one of the most dramatic scientific demonstrations in history. In 1648, Pascal convinced his brother-in-law, Florent Perrier, to carry a barometer up the Puy-de-Dôme mountain in central France. This wasn't a small undertaking. The mountain rises nearly 4,500 feet above the surrounding countryside. Perrier took meticulous measurements at the base of the mountain, showing the mercury standing at about 76 centimeters. Then he began the arduous climb. Imagine the scene: a man carefully climbing a mountain while protecting a fragile glass tube filled with toxic mercury, all in the name of science. It's remarkable nobody was poisoned in the process. Accompanying Perrier were several witnesses, including religious officials and local dignitaries. Science was becoming a public spectacle, with the natural world as its theater. When Perrier reached the summit and took new readings, the results were unmistakable. The mercury column stood more than 3 inches lower than at the base. As they descended, they took measurements at different elevations, watching as the mercury rose steadily with each step downward. The evidence was irrefutable. Air pressure decreased with altitude, just as Pascal had predicted. Pascal wrote triumphantly to Descartes, effectively saying, "Explain this if there's no such thing as air pressure." Descartes, never one to concede easily, maintained his position. But the scientific community was beginning to shift. Pascal's mountain experiment had provided the smoking gun that Torricelli's theory needed. This scientific battle wasn't just academic, it had religious dimensions too. Many religious authorities were uncomfortable with the idea of a vacuum, believing it contradicted the divine principle that nature contained no emptiness. Some even suggested that accepting the vacuum might open the door to atheism, as it implied limits to God's omnipresence. Could God exist in an empty space? These philosophical questions gave the barometer controversy profound theological significance. Adding another layer to this scientific drama was the fact that both Pascal and Torricelli were deeply religious men who saw no conflict between their scientific work and their faith. For them, discovering the laws of nature was a way of understanding God's creation more fully. The barometer controversy perfectly captures the tumultuous birth of modern science, a process not of calm, rational discourse, but of passionate argument, competing worldviews, and occasionally brilliant mountain climbing experiments. It wasn't just about measuring air pressure, it was about how we understand the physical world and our place within it. For Torricelli, who had died before Pascal's mountain experiment vindicated his theory, recognition came too late. But his legacy was secured by this dramatic scientific showdown that transformed a simple glass tube into one of the most important instruments in scientific history. When Evangelista Torricelli filled that glass tube with mercury in 1643, he couldn't possibly have known the far-reaching consequences his simple experiment would have across the centuries. The barometer wasn't just another scientific instrument. It was humanity's first real step toward mastering the weather, a force that had dictated human destiny since the dawn of civilization. From that modest beginning in a Florence workshop, we've come an extraordinarily long way. Today, networks of weather satellites orbit high above our planet, constantly monitoring atmospheric conditions. Supercomputers process billions of calculations per second, modeling weather systems so complex that they were once thought to be purely chaotic. Modern meteorologists can predict the path of a hurricane days in advance, giving communities precious time to evacuate and prepare. Storm warning systems save thousands of lives each year across the globe. But all of this incredible technology, all of our sophisticated weather prediction capabilities, can trace their origins back to that single moment when Torricelli discovered that air has weight and exerts pressure. Every time a meteorologist mentions a low-pressure system or a high-pressure front, they're speaking Torricelli's language. Every barometric reading taken by weather stations worldwide honors his discovery. There's a beautiful historical symmetry to how Torricelli's invention evolved. The first barometers were used primarily by individual ship captains and farmers making personal decisions. Then came networks of weather observers in the 18th century, sharing information across regions. The 19th century brought the telegraph, allowing pressure readings to be transmitted instantly across countries, creating the first true weather forecasting services. And now in our digital age, global weather monitoring systems gather millions of data points, creating forecasts of remarkable accuracy. One can't help but wonder, did Torricelli ever imagine the impact his invention would have? Did he lie awake at night, contemplating how his mercury tube might someday help sailors navigate safely through storms? Could he have envisioned that his discovery would eventually lead to technologies that would save countless lives during hurricanes, blizzards, and tornadoes? We'll never know for certain, but there's a touching story about Torricelli that suggests he understood the human significance of his work. Shortly before his untimely death at 39, he reportedly told a student, "In measuring the weight of air, we measure the very breath of God that sustains us." Whether these words are authentic or apocryphal, they capture something profound about Torricelli's legacy. His work connected the abstract realm of physics to the everyday human experience of weather, breath, and life itself. The barometer also teaches us something important about scientific progress. Revolutionary discoveries rarely happen in isolation. Torricelli built upon Galileo's observations. Pascal confirmed Torricelli's theories. Each scientist adding their own piece to a greater puzzle. It's a humbling reminder that even our modern technological marvels stand upon foundations laid by brilliant minds centuries ago. Perhaps the most remarkable thing about the barometer is how fundamentally it changed our relationship with nature. Before scientific weather prediction, humans were at the mercy of storms and changing seasons, reacting to weather events after they occurred. The barometer gave us foresight, the ability to anticipate and prepare. It shifted us from being weather's victims to being informed participants, able to make decisions based on what might come rather than simply responding to what already had. In some ways, the barometer represents the very essence of scientific progress, taking something mysterious and seemingly uncontrollable, and through careful observation and brilliant insight, making it comprehensible, measurable, and ultimately more manageable. From a simple tube of mercury came our first real understanding of the atmosphere that surrounds us, the invisible ocean of air in which we all live. If you've enjoyed this journey through scientific history, please hit that like button and share this video with anyone who appreciates how science has shaped our world. Don't forget to subscribe to Modern Age Chronicles, where we bring the fascinating stories of the past to life. Join us next time as we unravel another mystery from the modern age, the era that laid the groundwork for our contemporary world. Until then, remember to look up occasionally at the sky above you, and perhaps give a quiet thanks to Evangelista Torricelli, whose genius helped us understand the invisible forces shaping our weather and our lives.